This resource is the fifth in a 5-part series on the normal distribution. Part 1 looks at the basics of the normal distribution. We discuss the distribution about the mean and the probability of an amount lying between integral multiples of the standard deviation. Part 2 considers the process of normalizing a value. Part 3 considers the probability a normally distributed value will lie in some range. Part 4 combines the ideas presented in Parts 2 and 3, finding percentages for examples that require normalizing the value first. Part 5 looks at how to find the variable value that define various percentile ranks in a population, which means a specified percentage of the population is less than that value for the variable. In the previous resources in this series, we knew specific values from a population, either as actual values or as the corresponding z-scores, and wanted to find percentages based off those scores. In other words, we knew the z-score and wanted to find the p-value. But what happens if we want to go the other way? What if we want to know the z-score that results in a specific p-value, as is the case with percentiles? For example, what z-score corresponds to the upper quartile, which is greater than 75% of all scores? Or what if we want to find out what value for a population member represents the 20th percentile? How can we answer these questions? To find the elusive z-score, we read the cumulative frequency table backwards. However, we have options based on exactly what percent we seek, as there are two different tables. If the percent is greater than 50%, we look at the z-score table comprised of positive values. Because the mean splits the population in half, any amount of standard deviations above the mean will have a cumulative frequency greater than 50%. If the p-value is less than 50%, look at the table for negative z-scores, or scores below the mean. Once we identify which chart we need to inspect, we look for the p-value inside the body of the chart. We want to get as close as possible to the decimal equivalent of the percentage. Once we find our percent, look at the leftmost column and the column heading to find the appropriate z-score. Let's look at some examples. Let's look at the two examples mentioned previously. Suppose we want to find the z-score that results in the upper quartile. This means we want to have a cumulative frequency of 75%. Since that percent is greater than 50%, we will look at the z-score table for positive values. Looking inside the table of values, the closest we can get to 75% is 0.7486. This corresponds to a z-score of 0.67. What if we want to find the z-score that results in the 20th percentile? This time, our percent is less than 50, so we will inspect the table for negative z-scores. The closest p-value to 20% we can find is 0.2005. This is a z-score of negative 0.84. How will this process work in the real world when we had to normalize the values to find the p-values? Recall the population of 10-week-old kittens. They had a mean weight of 25 ounces with a standard deviation of 4 ounces. How much would a kitten weigh if it is in the 90th percentile for weight? Since our percentage is greater than 50, we will look at the chart for positive z-scores. We look in the chart and find that the closest value we can find is 0.8997. This p-value results from a z-score of 1.28. However, we want to find the actual weight, not just the z-score. Recall that the formula for normalizing a value is z equals the quantity of x minus the mean mu divided by sigma, the standard deviation. Multiplying by sigma on both sides of the equation, then adding mu, we find that x equals the z-score multiplied by the standard deviation plus the mean. Our kitten will have a weight equal to 1.28 multiplied by 4 plus 25. So our kitten weighs 30.12 ounces. We have looked at the population of women aged 20 through 29 in previous resources and discovered that the average height is 64.1 inches with a standard deviation of 2.75 inches. What is the height of a woman taller than 1/3 of this population? For this example, we want a percent less than 50. We need to look at the table of values for negative z-scores. We want to find the decimal equivalent of 1/3, but the closest we can get is 0.3336. This is the p-value for a z-score of negative 0.43. Plugging into our formula, the woman's height is equal to negative 0.43 multiplied by 2.75 plus 64.1. So a woman that is 62.9 inches tall is taller than 1/3 of the population of 20-something women.